5b, congruent polygons. So when polygons are congruent, that means that all corresponding angles are congruent and all corresponding sides are congruent. Okay, if both of those things are true, then that means the triangles, or the triangles or any type of polygons themselves are congruent. Okay. So looking at this example down below, I can see, oh, there's corresponding sides where the 1 dashes are and where the 2 dashes and so forth. And the same thing with the angles. The angles all have matching angles too, so I can say that these whole triangles are congruent. Okay. So sometimes you'll see you'll see the term corresponding parts. And when we talk about corresponding parts, we mean the sides and the angles, okay? So these are congruent triangles. Let's make a congruent statement. Here's how a congruent statement works. I'm just going to identify the triangle on the left. I'll call that triangle ABC, but you could put those letters in any order, right? But it's that triangle. And then I want to say that that's congruent to the other triangle. But here's the thing. I need to make sure that I get the letters in the correct spot when I write the name of the second triangle. Okay, so it's not necessarily always going to be alphabetical. So I put A in the first slot here. So I need to put the congruent angle in the same slot over here. So that matches up with the E, right? The A and the E are in the same slot because they're congruent angles. Okay, and I'm going to do the same thing with, hey, the B is going to match up with the F because they both have the 1 dash in them. So in my second slot, I need an F then. Okay, and then third slot, let's see, C is going to match up with D. Okay, so you can name the first triangle however you want, but then when you name the second triangle, you got to have the pieces in the same slots, the corresponding pieces in the same slots. Okay, so let's take a look at this one. These aren't triangles, these are quadrilaterals here, and it says that they're congruent in the directions. Okay, we're going to solve for x. So what I'm going to do first is kind of scan the diagram and find, okay, where is an x in this diagram? And there's 2 spots where it is. I'm going to use this spot. So what I want to do is figure out QR, this side QR, is going to be congruent to something. And you can do it visually, but the diagrams may not be to scale. So what you really want to do to make sure you get the right piece is to use the congruent statement so that we have up here. So QR, that's the last 2 letters of that one. So I take the last 2 letters of this, which is the FG, and now I can see, okay, those 2 sides are the matching sides. So now I can say that 2x minus 4 is going to equal 12. Okay, and I can solve that for x by adding 4 and then dividing by 2. Okay. All right, let's solve for y. So there's only one place where there's a y. That's right here with this angle. So I want to find the matching angle. And Q is the 3rd letter here, so I choose the 3rd letter out there, which is F. So that means that those must be congruent angles. So now I can say that 6y plus x is going to equal 68. Okay. And now, if I didn't know what x is, I'd be stuck here because I have 2 variables, but I already found that x is 8, right? So I can plug 8 into this. And now I can solve this for y. So let's subtract 8. And divide by 6. Okay. All right. Okay. So now let's talk about something called the triangle third angle theorem. Okay, so in my if statement here, you can see that angle A and D are congruent, and also angle B and angle E are congruent. All right, so let's just make up some angle measures here. Let's say that this is 28 degrees, so this would be 28 as well. And let's say that angle B is, I don't know, 92 degrees. Okay. Now I know in both of these triangles, the third angle, all three angles add up to 180. So in the first triangle here, I could say the measure of angle C plus 28 degrees plus 92 degrees is going to equal 180. Okay, I didn't leave myself much space here, but first I'd combine those. So let's find angle C here. So 28 and 92 would give me 120. Okay, and then I'd subtract 120 from both sides, and the measure of angle C is going to be 60 degrees. Okay, so hey, I know this third angle is 60 degrees, and it'll be the exact same math if I was looking for angle F in the second triangle, because it's the same numbers. So that means if two of the three angles are congruent, then the third angles are going to be congruent as well, okay? So that means angle C would be congruent to angle F. They would both be 60 degrees with the numbers that I made up right here, so that means they'd both be congruent to each other, okay? All right, so let's look at this. This says, are these triangles congruent? And we're going to explain. So at this point, there are shortcuts we're going to get to later in the chapter, but at this point we need to show that all the sides and all of the angles are congruent, okay? So let's start with the angles. Got the angles at the top that are congruent. That's good, here and here. Got the right angles that are congruent, okay? But the third angles aren't marked. But now I can use this new theorem that I found. Even though I don't know the measures of these angles, I know if two of the three angles are congruent, then the third set of angles is going to be congruent. Okay, and I could say the right angles are congruent too. If you wanted to get technical, that'd be the right angles congruence theorem. But I'm just going to say I used the triangle third angle theorem there. Okay, I'm abbreviating here. I used the triangle third angle theorem, okay, to show that angle A is congruent to angle C, okay? Okay, and then let's see, what else do I need to do? I also need to show that all three sides are congruent. I've got the sides at the bottom. I've got these sides. The third set of sides is not marked as congruent. Now, the third set of sides is actually the same line segment. Okay, so now I can say, okay, this line segment is congruent to itself. So I'm putting 3 ticks on either side like that. So this is the reflexive property that I'm using here, okay? So now I can use the reflexive property of congruence, which says that anything is congruent to itself. Reflexive property of congruence tells me that BD is going to be congruent to itself. Okay, and now that I've got all the sides and all the angles marked congruent, then I can say that yes, these triangles are congruent. And if I needed to justify that, I'd say all corresponding parts are congruent. Okay. All right. Let's try another one. Are these triangles congruent? Well, looking at the sides, we're good to go on the sides. The angles, nothing is marked yet on the angles, but let's see if we can find any of the angles. Okay, so let's see. Hey, those have to be congruent because they're vertical angles, right? I don't want to call those angle C because it's not clear what I mean if I say angle C. So I'll call the one on the left angle ACB. I can say angle ACB is congruent to the one on the right. I'll call angle DCE. Okay, and I use the vertical angles theorem. Okay, what else? Let's see. Now, it's hard to see here, but I do have these little markings that show that I've got parallel lines. Okay, so if I extend these parallel lines, then I can do something with a transversal. So you could pick either the other lines as a transversal. Let's say I picked this one as a transversal. Well, then if I look at this angle and this angle, they're going to be congruent because they're alternate interior angles. Different sides of the transversal, inside the tracks, those are alternate interior angles, okay? So now I can say that angle A is congruent to angle E by alternate interior angles theorem. Okay, and you could do the same thing using the other transversal to get angles B and D, or now you could use the third angle theorem since we've got two of the three. So either way, now I know that this angle is also going to be congruent to that. So again, you could do alternate interiors again, or you could do the triangle third angle theorem. I think I'll do a triangle third angle theorem just to mix it up. Okay, and now I've got everything's congruent, so now I can answer the question, yes, these are congruent, and I would say all corresponding parts are congruent. Okay. All right, that is the end of the section, and I'll see you next time.